Hello, my name is Brice Saunders, and I am here to talk about the wonders of maglev trains. What are they, how do they work, and why are they important are some of the key questions that I will be answering in this presentation. There is an incredible amount of science that goes into maglev trains that allow them to easily reach speeds of 200 miles per hour and faster. With speeds like this comes physical difficulties, but numerous amazing benefits to city development, urban structures, and transportation. What are maglev trains? Maglev trains are a type of train that can reach high speeds and utilizes magnetic propulsion to achieve this. These types of trains are used to transport large amounts of people in a short amount of time. Most modern countries have at least one high-speed train, but only 3 countries have a working maglev train: China, Japan, and South Korea. Between these countries, there are 6 operational maglev trains, and only one operates at a speed of above 200 miles per hour, which is the Shangji maglev in China. There is a maglev in Japan that is still under construction that offers an amazing speed of 311 miles per hour, but is still undergoing construction due to delays. In 2015, the Japanese L0 series maglev hit a top speed of 375 miles per hour. Why maglev trains? Why should anybody be interested in maglev trains? If utilized correctly, these trains could change how we travel between cities and could affect city development. Imagine the possibilities of being able to travel at 311 miles per hour. You could live in Los Angeles and take a day trip to San Francisco. You would be able to avoid the hassle of driving or flying, as it would be as simple as getting on a maglev train. These trains are powered by electricity and can possibly help reduce pollution by taking cars off of the road and stopping overcrowding. This will be talked about more in depth later on. Once built, maglev trains are relatively easy to maintain. The reason for this is their ability to float above the surface and the lack of wheels. Without this constant friction that causes things to wear down, maintenance is not a constant necessity. The development of high-speed rails. The development of high-speed rails is interesting, as the history goes back to the early 1900s, but that will be talked about later. A maglev train is considered a high-speed railway. As mentioned previously, there are only 3 countries that possess an operational maglev train, but other countries possess high-speed rails. What is the difference, and why does the United States have neither? The difference between a high-speed rail and a maglev high-speed rail is that one uses magnetic propulsion and the other uses your standard railway tracks and wheels. Maglev trains tend to be faster and smoother as they don't come into contact with anything, but standard high-speed rails tend to have a cheaper startup cost and have more experience behind them. Unfortunately, the United States doesn't have neither a maglev system or a high-speed rail system, and the simple answer is the distance and cost. The United States is a huge country, and unfortunately, due to that size, it becomes a difficult task to install and maintain high-speed railway tracks or maglev tracks, as it is costly and very time-consuming. The history of maglev trains. What about the history of maglev trains? The first person to develop a simple maglev train was German engineer Alfred Zedin, who in 1905 patented the idea of a motor that would propel a train using a magnetic field. It took several years before his idea was expanded on, and several more before it was put into practice. The relationship between urban growth and trains. This idea of trains has been important for our country as a whole. It is thanks to the advent of trains that American society developed west. Trains have been used for a long time. They have aided the growth in society and cities around the world. When early Americans started to move west, trains soon followed, bringing trade, goods, transportation, and jobs. The world became more connected thanks to the widespread and easily availability of trains. Now, how does all of this relate to maglev trains? Imagine a society where you can live in one major city and in your average commute be in another major city. The jobs that would be created would be amazing. You would be able to fit more people, transport them faster, and not only freeing up space, but also helping reduce pollution by keeping cars off of the road. The benefits of a large-scale maglev train is that it would connect all of the major cities in the United States and would outweigh any negatives and would beneficially change our society as a whole. What does maglev have to do with any of this? Maglev trains are trains, and they are faster than our standard diesel locomotives. The standard diesel locomotive has a speed of around 90 to 80 miles per hour, while the average maglev train is 200 to 300 miles per hour, which is the average speed, which with the average speed of a maglev train being significantly faster, it would make travel between cities seamless and incredibly fast. The benefits of faster transportation between cities and how that helps and how does that help with urban growth? If you take a look at the 215 freeway on a Tuesday at 5 p.m., the traffic is completely obnoxious. But now imagine if there were 4 maglev trains taking people to and from their locations for work. The freeway would be clear, helping prevent congestion and curbing urban growth as well as the pollution in the area. Now we get to the fun part. How do maglev trains do it? Now, how do maglev trains hit these incredible speeds with less pollution while being more energy efficient? We have to take a look at how maglev trains are propelled. There are 2 different types of ways to propel a maglev train. The first is electromagnetic suspension, EMS. This is when you use the attractive force that a magnet has to your advantage, allowing stationary magnets to repel against the magnets on the guide rail. This allows the train to float above ground. Once a current is then run through the train, we get alternating currents, which allows the train to be propelled. This would be an issue if we didn't have guidance electromagnets. These alternating currents are utilized by the guidance electromagnets to propel the train forward and make sure that it doesn't fall off of the track. The other method, electrodynamic suspension, EDS, uses supercooled, superconducting magnets to generate almost zero electrical resistance and a very strong magnetic field. There are 2 different sets of magnets, a lower part and an upper part. The lower part has the same polarity as the magnets in the train, and the upper part has different polarity. This alternating polarity is what causes the train to move forward. Trains that use this method need to have wheels that once hit top speed retract and allow the train to float seamlessly. Unfortunately, these trains have to have a constant supply of liquid nitrogens to keep the magnets in a state of superconductivity. All this is important for reducing the amount of friction that is felt on a train. With the lack of moving and rubbing parts, friction becomes almost negligible, which is why the high speeds can be achieved. There is another important factor in speed, air resistance. Unlike most physics problems, where we ignore air resistance, this is real life, and at speeds of up to 200 miles per hour, air resistance plays an important role in the top speed achievable. To negate as much air resistance as possible, maglev trains, as well as most high-speed trains, incorporate aerodynamic designs to help reduce air resistance. Energy plays an important role in how maglev trains operate. Not only do they rely on inducing the magnetic fields, but they also need to power the amenities inside the train. The fortunate thing about maglev trains is that they are directly connected to the power grid, which allows them to be more efficient and enables the train to operate without producing pollution. Speaking of pollution, a major benefit of the maglev train is the ability to transport a large portion of people in a smaller space than what would be needed to transport them by car. The Shaanxi maglev, located in eastern China, can hold up to 574 passengers and can hit speeds of up to 268 miles per hour, all while having the width of 37 meters. A big contributor is cars. A big contributor to pollution is cars. Assuming that there are 2 people for each car, you would need to have 287 cars to match the same amount of people that a single electric-powered maglev train that can can transport. This means that if an operational maglev system is up and running, there would be a significant reduction in cars and in turn a significant reduction in carbon emissions. Thank you for taking the time to listen to my presentation. I greatly appreciate it.